I'm suggesting that you're this, you see, and you say, you can test it, and it will say yes or no to that. And if I've got my theory right, I can say, is this you? I mean, is the world this particular wave function? And you can, in theory, set up an experiment where it will say yes with certainty, that that is what it is. And so, to me, that gives it a reality, that the potential of testing it in that way. This was what Einstein had, an element of reality. It was Einstein thought quite deeply about these things, and he argued that this means that thing is real in a certain sense. It has an element of reality, I think is what he said. And I'm going along with that. The only trouble with it goes wrong was when you get ridiculous answers. And one of the ridiculous answers is with the Schrödinger cat, where the wave function seems to be saying that the cat is alive and dead at the same time, which to me is a ridiculous answer, and to Schrödinger was a ridiculous answer. So the thing is, it says to me, is that the Schrödinger equation is not right at that level. Something has happened to the world. Okay, the wave function was really correctly describing the world at one stage. It evolved to a certain stage, and then it did something which the Schrödinger equation does not tell you. The Schrödinger equation gives up at that point and tells you to look for probabilities. You've measured it, this thing. The measurement means that the measuring device has got entangled with the system you're looking at, and now the system has got bigger. It includes the measuring device as well. The measuring device can do one thing or another, rather than doing a superposition of one thing and another. So something has changed. So if you're allowed to say that the Schrödinger equation isn't completely right, when the system gets big enough in some sense, something else happens rather than the unitary evolution, which is the Schrödinger equation, then, okay, I don't see anything wrong. I mean, there are difficulties when you talk about non-local effects and so on. Okay, well, we have to worry about these things. But I can't see anything wrong with saying that the Schrödinger equation is real. It's just that the wave function is real, but it's not. The evolution, which is given by the Schrödinger equation, is only correct up to a certain point. When mass gets displaced too much, and then you need to bring in something else which closely resembles the collapse of the wave function which we actually see. So I'm taking a very realistic in the sense of philosophical. I'm saying I'm allowed to say that the mathematical description that we're using up to a point is really describing the world. But the world at a certain point does not behave according to the Schrödinger equation. It behaves more like the procedure we use when we make a measurement. It's got to join up between those two in a nice way, coherent way, which it doesn't at the moment. You just have one end of the story and the other end of the story. We don't know what happens in the middle. But that's where I think we're missing a theory. So I think it doesn't seem to me that it's an inconsistent ontology. It's just that we don't have the right theory yet. So I think that would be my answer to the question. Yes?
I got a question which is a little bit in the middle of the previous
Yes?
You told us about the new physics that we need to develop in order to somehow get rid of those inconsistencies.
Yeah.
But people from the ancient Greeks up to today, they always wanted to seek. We call it today the theory of everything, like the arche at the beginning and now this theory. Do you think that there is one? So do you think that we can construct the system, the theoretical system, which can describe everything in the future and in the past and
well, I wouldn't
at this moment?
necessarily expect that it would.
It's just a
It's not working. So okay. Sorry, I hope that's better.
right?
It's all right for me. Is it all right at the back of the room? Is the question.
Okay.
Yes, that's a good thumb up. Thank you. Well, of course, I wouldn't like to predict the future in two senses. One of them being that I don't demand that if we had a theory of so-called everything, which I don't like the term because it's, I think on the one hand it's giving me physicists a bit too much say in what means everything. I mean, it's not really. Okay, let's talk about physics. I mean, that's what we're going to talk about here. We certainly don't have it yet, in my view, because there are huge gaps, and I think the hugest gap so far, we may find huger ones later on, the hugest gap so far is in quantum mechanics, is that it's not finished. That we have to complete the theory in a way which allows the measurement process to be part of the theory, which it's not at the moment. So I'm talking speculatively about things which we certainly haven't got to that stage. You're really asking me whether I think there ever will be such a theory. Well, you see, it could well be that such an attempt at such a theory, the best we can do, might still not be predictive. You see, it could well be that it's indeterministic in the way that current quantum mechanics is, and that the theory only tells you the deterministic part of the scheme. It doesn't tell you anything about where there's freedom in behavior, which there could be. Now, this freedom could be entirely statistical, or it could relate to what we call free will, and so on. You see, there may be, relating to the first question, whether there is something going on in the reduction of the state which is related to what we call free will. Maybe there is something there which is freedom in the physical laws. I don't want to say anything about whether I believe that or not. I'm just saying that that's a possibility. There could be freedom in the physical laws, and it could be that that freedom, whatever it is something which is being exercised in our free wills, if there is such a thing. I'm not, as I said, making a claim one way or the other. But I think your question was somehow implying that an ultimate theory, so-called theory of everything, would be one in which the future would be exactly predictable. And it might not be. You see, it might be that it's a theory of everything that we could have a theory of and still not be a theory of everything. So that's a possibility. And I suppose I'm slightly swinging to that view just recently. I don't think I liked it very much previously. I'm not sure whether I still like it very much, but there is something in allowing that kind of freedom, certainly a statistical freedom, which allows you to do things which you're in trouble with otherwise. So it may be that there is something, whether it's purely random or whether there is something of the nature of some kind of control that conscious beings can exert, which is certainly the way we feel about things. Whether it's true or not is another question. So that's a very incomplete answer to your question. I suppose I think that ultimately, if we survive that long, which is not altogether clear, that we might get to a point where we will have a theory which is as good as it can be, in that sense. And if so, it would have to be of a very different character from physics that we know today. There's a question back there. Yes.
So, in your book, The Road to Reality, you mentioned that it's hard for physicists to pursue unpopular ideas, not to follow the crowd. But it seems to me that there is an activity which is the attempt to solve the problems in critical phenomena in condensed matter physics by the string theory, via the holographic principle.
Uh-huh.
And what do you think about this? And
well, I'm speaking from ignorance to some degree. I know there are parts of condensed matter physics where people say that they can appeal to the ADS-CFT conjecture or something, and there are parts of physics which seem to make use of some of these ideas. Maybe they do. I have nothing against that. It doesn't conflict with the sort of views which I hold on if you ask me about string theory and where I think it's going, well, I'm not sure where it's going with regard to physics. It certainly has made it's had a big influence on mathematics. And there are certainly instances where parts of mathematics have been revolutionized by ideas which have come from string theory. Or perhaps I should say from certain particular individuals who are string theorists. Whether that is string theory, I'm not sure. But my main trouble with string theory is not the strings, which are a nice idea. I never had worried, I thought the idea, whether right or wrong, I thought it was a nice idea, certainly when I first heard about them. What I object to is the superdimensionality, the fact that one seems to be driven to spatial dimensions which are supposed to be wrapped up into tiny little knots.